Okay, for those of you listening at home, I deeply apologize. I went spazzing off. We're checking out the last page of 14b-1, which is solving for theta. I'll try and record a video on this. I'll try and record a video on this tonight for you if you get stuck. But the main idea is, if you have a formula, excuse me, people are chit-chatting. I won't be able to hear. If you have a formula where you have two different functions all together, you've got to get them all as one function. Then you can use the master formulas, 1, 2, 3, and 4, to rewrite them. Cotangent is really, if you use master formula number 4, cotangent is really cosecant squared minus 1. If you plug that in, I mean, just looking at nowhere else, everything is cosecant now. That's a good thing. Then, since there's two different species of cosecant, you got to get the answer down to 0. Can't solve with algebra. Blah, 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 and you get this. This factors. This is sort of like u squared plus 3u plus 2. It uncoils to this and this. Solve it into cosecant equals -2, cosecant equals -1. I forgot which number this was, but it was one before. And then, cosecant is not on the inner circle. It's the reciprocal of sine. Take the reciprocal of both sides, and solve for these. The only catch is, do them in radians. So this particular one, what is that one anyway?
Number 13.
That's number 13? Okay. Yeah, this is the thing. This is number 13. 12?
12. Sorry.
This number, no, it's all right. So number 12 should give you 3 solutions. Theta equals 7 pi over 6. Theta equals 11 pi over 6. And theta equals 3 pi over 2. Because that's the only place where sine is -1. Okay? And then this one we're just about to go through. This is number 14. Now, here's the original thing. Again, mismatch of functions. We can't solve the problem as is. If you rewrite sine squared as cosine squared, using master formula number 1, because you ignore that one, here, sine squared is equal to 1 minus cosine squared. Let's do it now. Cosine of theta plus cosine squared of theta equals 1 minus cosine squared of theta. Now you notice there are two different species of cosine. I cannot solve with algebra. Got to get this answer down to 0. So add cosine squared to both sides. And then subtract 1 from both sides. You should get, if I put them in order, these are both like terms. 2 cosine squared of theta plus cosine squared of theta, or root cosine regular of theta, minus 1 equals 0. I'm going to deliberately substitute this one because this looks a little harder. If you substitute u for that weird looking cosine, you get this. 2u squared plus u minus 1 equals 0. And the question is, does that factor? Turns out it does, but you have to do something called magic pair. Multiply the first and the last terms, -2u squared, and then give me all the pairs that multiply together. I have 1u times -2u, 2u times -1u. I think that's it. Do you want to know this work? Let me see. Austin, take over.
Yes.
Which one?
Would it be
Top or bottom? Is it 1u times -2 or 2u times -1u?
2u times -1u?
How come?
Isn't it because, like, well, at least back in the equation it was a positive. Well, I can't really remember why it was.
Okay. In magic pair, you multiply the first and last. Go ahead, kid. They add up to the middle term. Right. That's how you know if it's a magic pair or not. These add up to positive 1u, and they do. So you replace that. You put a plus here. Replace the magic pair of the middle term. 2u squared plus 2u plus 1u, -1u, sorry, plus -1 equals 0. How do you finish this thing? Well, factor by grouping, remembering people. Say that fast. Abby, what do you think? 4 terms. How do you factor that? You could, is there one?
I would say -1, but.
Partially right. There's not an overall GCF of -1, but there is just here. What's it called? There's 7 basic methods of factoring. GCF, unfoil, binomial squared, difference of 2 squares, grouping, magic pair, substitution.
Oh, grouping.
Grouping. Ding, 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 ding. Go ahead and do it for me. Is there a little mini GCF for this one?
2.
2 and also
Oh, 2 U.
a U. What's left?
U plus 1.
Good. I like the +1. A lot of people just put blank.
And then that one's -1,
Huh?
and it's just U plus 1.
Correct. +1, because the negative is the yin. Is this going to work?
Yes.
Yes. What do I do with the U plus 1? It's a common factor, so what do you do with a common factor?
You just group them together.
Yeah, pull them in front, group them together. So, kind of like you did with the U up here. Like you did with U.
Plus 1.
I hate when they use the U, but to you, from me.
2U plus.
Anyway, so go ahead.
2U
And then
plus -1.
2U plus -1 equals 0. I'm gonna do this. It's getting really hard. But, okay, Courtney, take over, and then please be quick.
Okay, U plus 1 equals 0,
Good, thank you.
and then 2U plus -1 equals 0.
Okay, so, U equals,
Oh,
this is silly, I'm just doing that.
1.
Almost.
-1.
-1, good. It's okay, you can slow it down.
Yeah, and
I'm
then,
not telling you.
so you add 1,
Okay,
and then 2U equals 1,
2 equals 1, and U equals
1.
1/2, exactly. Now, those are great. What is U in this particular case? Yeah, cosine of theta. Let's put those back where we found them. So we've got cosine of theta equals -1, and cosine of theta equals 1/2. Now, finish the problem for me, Spencer. Is cosine ever equal to -1? What is cosine in the unit circle? It's left, right. Is it left or is it right? Left. How far? Yes. What is that in radians? Pi. Right. So you've got one solution so far, theta's pi, and Sam, take over. Is cosine ever, is this common or uncommon?
Common.
Common. Multiple of what?
30.
30. Is cosine left, right, or up, down?
Left, right.
Is this left or right?
It's right.
To the right. A lot or a little?
A little.
A little. Where are we?
So 60 and
Yep.
3,
And what?
300.
300. Could those be in radians? What's 60 in radian?
Pi over 3.
Yep. How about 300? What multiple is this?
5 pi over 3.
Exactly. 5 pi over 3. So you got 2 more solutions. Pi over 3, 5 pi over 3. Yeah.
I go to 5.
Go for it. Just leave the door open. Or a crack. Good to go? All right. Take out your notes, please. We're talking about angle addition formula. Today I get to give you the third angle addition formula as well. Is Mr. writing this down there? Okay. You can also check out the YouTube video for this today. And by the way, this totally sounds like a joke, but if you click subscribe, you actually, I'm not gonna get any micro, money, transactions, don't worry. But you will get notified whenever I post a video, and you won't have to go searching for the link. It'll just come right in your inbox, so, thank you, Google, for once in your life. Now, angle addition. Let me just summarize what we had so far. The first formula we had was sine A plus or minus B. The first angle addition formula we have is for sine. Can somebody give me the formula? Very quick. Give me your notes if you need to. Sine of A, cosine of B. Yep. Or actually, oh, it goes SCCS. So cosine of what? Okay. The angles will always come in the same order. So it'll be AB, and then sine of B. Correct. And I will put plus minus here. There's the angle addition formula for sine. It also works for subtraction. The roots of it. Let's try it out. I would like you to find me the sine of 15 degrees. And I want the exact answer. Normally, this is not a common angle. 15 degrees is not a multiple of 30, not a multiple of 45. It's an uncommon angle, which means we normally have to use calculator. But I want the exact answers. Any ideas how? Yeah. Right. You can turn it into a subtraction problem. If you can find two angles that add or subtract to be 15, you're in business. And 45 degrees minus 30 degrees looks like it's a good candidate. By the way, is that the only pair you could use? No, give me another pair you could use. Anyway. 45 and 30 are nice. Is there another pair that would give you the 15? I can think of another pair that's not too bad. Hey. 45 minus 30 is 15. Can you think of two other common angles that subtract to be 15? 60 and 45. Right. You can also do 135 minus 120, although that's getting clunky. Does that make sense? It really doesn't matter what two angles you use. I would just suggest you use easy ones. So, can somebody track through the entire formula for me? Use that and these. Let me see. Katie, help me out with this. Good. Sine of 45. And I'm sorry, what was it? We're doing this part. Good. Gentlemen, I need your focus up here, please. Not on each other. Go ahead. Cosine of negative 30, correct. Or you can just do the minus here. That's fine. Cosine of 30. Minus. Good. And then what? Good. Sine of 30. In other words, if you have a plus here, you have a plus here. If you have a minus here, you have a minus here. Make sense? Let's do it. Can somebody tell me the sine of 45? It'll be something times something minus something times something. They're all going to be fractions. Now, do your common angles. Yeah.
Radical 2 over 2.
Radical 2 over 2. What's the cosine of 30?
Radical 3 over 2.
Radical 3 over 2. And then cosine of 45?
Radical 2 over 2.
Radical 2 over 2 again. And then sine of 30?
1/2.
Good. Those, take 30 seconds off to the side, a unit circle, figure out what those are. Or you can draw the 45, 45, 90 triangle or the 30, 60, 90 triangle if it helps. Can somebody multiply these for me? What's a radical times a radical, by the way?
A radical.
A radical.
A radical 6.
Yep. Over
4.
4 minus
Just radical 2.
radical 2 over
4.
And you've got a common denominator, so put them together. By the way, is radical 6 minus radical 2 equal to radical 4? No, they're not like terms. So, Will, take over. What is the final answer?
Square root of 6 minus square
Don't do anything with the top. You can't simplify. You're done. Does that make sense? That is the exact answer for the sine of 15. It looks a little clunkier than normal, but it's exact. It's not just a decimal. Cosine of A plus or minus B. And somebody give me the formula for that. Dig in your notes if you need. Everybody find it? Did I give this to you last week? I didn't give you cosine? Oh, shame on me. Hold on. All right. So, go ahead and write this one down. It's actually a little easier, sort of. Cosine of A, cosine of B. This one's a teeny bit tricky. Look up here. Minus plus. I did that for a reason. Sine of A, sine of B. Now, what does this minus plus mean? Now, in reality, plus minus and minus plus mean the same thing. But that means if this first one is plus, what would the second one be? Minus. And if this is minus, this would be plus. Does that make sense? So if I wanted to find the cosine of 15 degrees, I'm going to kind of turbo through this. It's going to be, I'm going to choose that 45 minus 30. That worked pretty well. So this is A and this is B. So cosine of 45, cosine of 30. They have a minus, so we use what? Anyway, plus. And then sine of 45, sine of 30. And again, those are common. Should be able to find those with the unit circle or 30, 60, 90 triangle. Is pren plus pren. Radical 2 over 2 times radical 3 over 2 plus radical 2 over 2 times 1/2. Should give radical 6 over 4 plus radical 2 over 4, or radical 6 plus radical 2 over 4. If you notice, it looks hauntingly like sine of 15. There's just one difference. Plus. I'm actually going to give you a bit of a hint in about 5 minutes that could, if you memorize it, speed up your multiples of 15 quite a bit. Yeah.
Why is it like minus plus,
Right here?
Yeah.
Yeah, that means if it's plus here, it'll be minus here.
Oh.
If it's minus here, it'll be plus here.
Thank you.
So, I need to give you one more formula first though. Tangent of A plus or minus B. I will warn you, this is the strangest of them all, although it is a little shorter. It's a fraction. The top, tangent of A plus or minus tangent of B. Try and write that down. And on the bottom, make this a little longer, 1 minus plus. I'll ask what that means in a second. Tangent of A times tangent of B. What actually happened in the past is, you remember the tangent is sine over cosine? They could write this mass over this mass. And somebody did hundreds of years ago, did all the hard work of boiling it down for you. You're welcome. On behalf of whoever that is, pray for their soul. So, do you notice that if this one is plus, if the original problem is adding the two angles, what's this going to be? Anyway. Add. What's this going to be? Subtract it. It's just going to be the opposite. So if this is plus, this will be plus, this will be minus. What if the original one is minus? What's this? Anyway. If this is minus, they match up. You notice they have the exact same. If this is minus, then this is minus, but this will be plus. Make sense? The minus plus just means use the opposite sign. Plus minus means use the same sign. Okay. Let me give you a tangent demo. I will tell you right now, this is probably going to hurt a little bit, but I will give you a shortcut when you're done as a reward. What is the tangent of 15 degrees? Spencer, take over. What two angles do you think we could pull off with this? Definitely. Add a subtraction. Definitely. So I'm going to do the tangent of 45 degrees minus 30 degrees. So use the tangent subtraction formula for me.
Tangent.
Yep.
45 plus tangent of 30.
Sort of. Tangent of 45 minus tangent of 30, because the original was minus. Okay.
And then over
1
plus
plus, good.
the tangent of 45 tangent of 30.
Yeah, tangent of 45 times the tangent of 30. Part of the reason this is annoying is because we're going to have fractions over fractions. We'll have to get the radicals out of the basement, and we're going to have to get the dividing by a fraction. Once you get those done, it's actually not too bad. So, Rainey, help me out with the top. What's the tangent of 45 degrees? It is 1. What's the tangent of 30 degrees? Chelsea. Or, what the heck? I just promoted you to secretary. Sorry. I've been saying her name a lot this day. Sorry. My bad. So, sorry. I'm sorry. No, I'm calling on your name now. So, what is the tangent of 30 degrees? Common or uncommon? Common. Is it multiple of what? I mean, obviously. 30. What are the two fractions for tangent? The two slopes for tangent. Remember? Yeah.
Radical 3 or radical 3 over 3?
Radical 3? Radical 3 over 3. Which one's bigger? Radical 3. Which one's smaller?
Radical 3 over
Which one is this? What is tangent on the end circle?
slope.
Yeah. Here's 30, here's 60. Is that the bigger slope or the smaller slope? Smaller. So what is it?
Radical 3 over 3.
Exactly. Now, take over the bottom, Abby.
So 1
1
plus.
plus. Now, part of this is easier because the numbers are already there. Just copy and paste them.
1 plus 1
Times.
times radical 3 over 3.
Right. So give me what you have so far. What's on the top?
1 minus radical 3 over 3.
Okay. Over.
Divided by 1 plus 1 times
What is 1 times that?
radical 3 over 3.
Just radical 3 over 3. That is your answer, but it's not simplified. Does that make sense, Laura? I want a common denominator. So, right there, take over. What common denominator would work? 3. So this is what over 3, really? 3 over 3. Everybody see that? 1 is really 3 over 3. I'm going to do that down here too. So I'm going to rewrite this as a common denominator fraction. What would that look like? There's not much you can do. Yeah, 3 minus radical 3 over 3. That's all you can do. Common denominator. And then do the bottom formula, right? How do you divide by a fraction? Okay. Nate, take over. Multiply with the reciprocal for me. So what's the first thing you write?
Times.
Before that. What's the first thingy that you're multiplying? So this thing divided by this thing is really what?
So 3 minus radical 3 over 3
Oh, 3
times
times
3
times threes cancel. What are you left with?
So it's three radical, three minus radical three
Okay,
over
over
three plus one.
3 plus radical 3. This looks much, much better, but it's not quite done. Why not? Thank you. Radical in the basement. What's the cure for that? This is what I used to call a hostage situation. By what? Normally, yes, but we have a hostage. How do you handle the hostage? Anybody? Can I remember? Yeah.
Multiply 3 minus radical 3.
Yeah, this is not as innocent as he thought. This is really radical 9. Kill it. But how do you cancel a plus? Anyway. Yeah.
Minus.
Yeah. Just do it to both sides. Okay, foiling people, your turn to shine. What's the top? Go.
It's just one.
Foil. So first,
Oh, wait,
outer,
multiply.
inner. Yeah.
Oh, okay. So 9.
9.
3 times, negative.
Minus 3.
3.
Yep. And then this one.
Minus.
Minus.
The same thing.
Another thing. Then what's negative radical 3 times negative radical 3? It's going to be negative or positive.
Positive.
Yep. And it was what? You said it.
Oh, wait, yeah, 3.
It is 3. Correct. And somebody can foil the bottom for me. Okay. First. 9. Outer.
Minus 3 radical
Minus 3 radical 3.
3.
Inner.
Plus 3 radical 3.
Plus 3 radical 3. Then radical 3 times negative radical 3.
Would be minus 3.
Exactly. Does anything simplify? Austin, take over.
At the top it becomes a 9 minus 6 radical 3
Those are like terms.
plus 3.
And then those are like terms too, so what do you get?
So then you get 12
Oh.
minus 6 radical 3.
Good.
And then the bottom you get,
Anything interesting yet?
well, the radicals cancel each other out.
Radicals cancel.
And then you get 6.
6. I'm going to have the opposite. Can somebody finish this problem for me? How do you simplify it? Can I just cancel the 6's? Why not? You're right. No. With the addition sign. How do you reduce this thing? Yeah. If the whole thing is divided by 6. Okay, go ahead. Each one by 6. So it's 12 over 6 plus negative 6 radical 3 over 6. Finish it off for me. Don't do it. 2 plus negative radical 3. That is your final answer. There are actually 2 things I have to tell you. Number 1, I'm actually going to bulk the assignment for Wednesday. Second of all, don't thank me yet, but you're welcome. I do have to give you the shortcuts I promised in the 1 minute. Oh, we're actually, my clock up there is late. Never mind, I'll tell you tomorrow. Please stand. Wow. Fix that lame on. Let us pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. All right. No problem, thank you. Thank you. Have a good day, y'all. Stay well, oh, and I gotta